People say pain is inevitable. But what if your brain itself had a kind of pain switch? A neural circuit that could turn off chronic pain when something more urgent needs your attention. That's exactly what a stunning new scientific discovery has just revealed. Today, I'll show you how scientists found a group of neurons in the brain that act like a biological priority system, deciding what matters most for your survival: feeling pain, or fighting, eating, escaping, or simply staying alive. And the most incredible part? These neurons may hold the key to new therapies that could finally relieve chronic pain without the side effects of common medications. But before we get to that, let's start with the basics. We all know what acute pain feels like, that sharp sting when you touch something hot, twist your ankle, or cut your finger. It's the body's alarm system saying, hey, something's wrong. Normally, once the injury heals, the pain goes away. But with chronic pain, that alarm never shuts off. Even after the body has healed, the brain keeps sending pain signals. Millions of people around the world live trapped in this endless alarm, suffering every single day without knowing why the pain won't stop. For decades, scientists have been trying to find out where and how this pain signal stays stuck. And now, finally, part of that mystery has been solved. In a new study published in the journal Nature earlier this year, in 2025, one of the most respected scientific journals in the world, researchers mapped the brains of animals living with chronic pain. They wanted to find which regions stayed active for long periods of time, even after the initial injury was gone. They discovered an area called the lateral parabrachial nucleus, or LPBN, located deep in the brainstem, the region that connects the spinal cord to higher brain centers. You can think of it as a traffic control tower. It receives pain signals from the spinal cord and decides how to pass them on to the rest of the brain. And inside that control tower, scientists found something special: a small group of neurons that carry what's called the Y1 receptor. These are the Y1 neurons, and they turned out to be the stars of this discovery. The researchers found that these Y1 neurons are constantly active during chronic pain. They don't just fire for a moment when pain starts. They stay switched on all the time, keeping the brain in a state of continuous suffering. So the scientists decided to test what would happen if they could turn those neurons off. And the result was astonishing. When the Y1 neurons were inhibited, the animal showed far fewer signs of chronic pain. But when the neurons were artificially activated, even without any injury, the animals behaved as if they were in pain again. In other words, these neurons aren't just messengers. They're the controllers of persistent pain. But the next experiment was even more fascinating. The scientists wanted to know what would happen if the animals, already in pain, were put in a situation of hunger, fear, or extreme thirst. And what they saw was almost unbelievable. The pain faded away. When the brain detected a more urgent survival need, like finding food, escaping a predator, or satisfying thirst, the activity of the Y1 neurons dropped dramatically. It was as if the brain said, "Now's not the time to feel pain. We need to survive first." This effect is driven by a natural brain chemical called neuropeptide Y, or NPY. It acts directly on those Y1 receptors, silencing the pain neurons temporarily. It's like NPY presses an internal survival mode button, and pain loses priority. Think about that for a moment. Your brain literally decides which sensation matters most. If the pain is critical for survival, like a burn or a wound, it stays on. But if pain gets in the way of something more urgent, like eating or escaping, the brain can lower it to help you survive first. It's a biological priority system. And now, for the first time, scientists have actually seen it in action, neuron by neuron. So what does this mean in practice? The researchers believe that understanding this circuit could lead to an entirely new class of chronic pain treatments, more precise and more effective than anything we have today. Instead of numbing the entire nervous system, like opioids or heavy painkillers do, these future therapies could target the Y1 neurons directly, adjusting the volume of pain instead of completely silencing it. Imagine someone who's lived with back pain for years. They've tried everything, medication, therapy, even surgery, but nothing helps. Now imagine being able to reprogram the brain so that it stops giving that pain top priority. That's the kind of breakthrough this discovery represents. The scientists also noticed something fascinating. The same Y1 system is connected to other brain networks that control emotion, motivation, and even hunger. That means pain isn't just physical. It's deeply linked to our emotional and biological states. And it makes sense. People with chronic pain often struggle with anxiety, depression, loss of appetite, and sleep problems. Now, for the first time, there's a biological explanation for that. The same neurons that modulate pain are also part of these vital functions. Of course, there are important limitations. So far, all of this has been observed in animal models. We don't yet know for sure if the same process happens exactly the same way in humans. And completely turning off pain would be dangerous. Pain has a protective purpose. The goal would be to find a balance to reduce chronic pain without eliminating the body's ability to sense when something is truly wrong. There's another challenge too. The NPY-Y1 system also regulates things like appetite and mood. So any therapy targeting it would need to be extremely precise to avoid unwanted side effects. Even so, the progress is monumental. For the first time, we have real evidence that chronic pain isn't just a physical problem, it's also a decision made by the brain. And maybe, with the right treatment, we could teach the brain to deprioritize pain and take back control. So think about the potential impact of this. If this research continues to advance, we could soon have drugs or brain stimulation technologies that activate or inhibit Y1 neurons only when necessary. Doctors might even monitor these neurons' activity to measure pain intensity or use the body's own NPY system to rebalance suffering. Think of it as a pain thermostat. When pain levels rise too high, the brain dials it back down. When it's important to feel pain again, it turns the signal back up. It would be the first truly adaptive treatment for chronic pain in the history of medicine. This discovery also brings hope, real hope, for people who wake up in pain, go to sleep in pain, and feel like their own body has turned against them. Maybe in the near future, the brain itself will be the medicine. Maybe there's a hidden switch that can restore life quality without chemical dependence, without devastating side effects. So next time someone says pain is inevitable, remember this. Science is showing that maybe it doesn't have to be eternal. The brain is far more powerful than we ever imagined, and deep inside it, hidden in the circuits of survival, there may be a small switch, one that decides when it's time to suffer and when it's time to live. If you've lived with pain for a long time, what would it mean to you to simply turn it off for a while? Do you believe science could really make that possible? Share your thoughts and your story in the comments. You might inspire someone who's going through the same struggle.
Did you enjoy the video? Subscribe to our channel, Health and Wellness for All, for more tips and information. See you soon.